Welcome to the next tutorial class. So, now in this tutorial class we will take the numerical problem on complex Poynting vector. So, this is the first problem. So, consider electric field equal to minus u by eta naught h naught e to the power minus j k z volt per meter and h is equal to u x u naught e to the power minus j k z ampere per meter, where h naught is 25 ampere per meter and frequency given is 30 gigahertz, propagation is in free space and z is in the vertical direction. That means, electric field has the direction minus u by, magnetic field has direction u x and z is the direction of propagation, that will be the E cross H, that will be the direction of propagation. Assume lossless propagation. Calculate the time average power density in the wave. So, this is the first problem, calculate the time average power density in the wave. In the next part, calculate the stored electric and magnetic energy density separately. So, let us do the solution. So, here it is given. So, it is the next problem. H is equal to u x h naught e to the power minus j k z ampere per meter. So, this is the complex the magnetic field. So, this a star of this will be this will be u x h naught e to the power j k z. So, this will be the h star. Time average Poynting vector will be time average Poynting vector is, it will be 1 by 2 real part of E cross H star. So, E is given in the question. So, it will be 1 by 2 real part of minus of u by eta naught h naught e to the power minus j k z cross with u x h naught e to the power plus j k z. So, real part of this. So, this will come e to the power j k z and e to the power minus j k z and plus j k z, it will be 1 and u by minus u by cross u x. So, that will be u z and real part this will be u z 1 by 2 eta naught h naught whole square watt per meter square. So, thus power is transferred in the positive z direction, because this is in the u z direction, and time average power density. So, this is the time average Poynting vector and time average power density will be time average power density is half of eta naught h naught square equal to, because in the question it is given, it is the means lossless propagation and propagation is in the free space. So, free space wave impedance will be 377. So, this eta naught will be 377 ohm into H naught is given, that is 25 ampere per meter, that 25 square, and so this will be answer for the first part will be 117.81 into 10 to the power 3 watt per meter square. In the next part, write the stored electric and magnetic energy density separately. So, in the B part, so Wm is defined as means time average stored electric and magnetic energy, that is denoted by Wm for the magnetic. So, 1 by 4 mu naught H and H star, 1 by 4 mu naught, H value is ux H naught, ux H naught e to the power minus j k z, that is into ux, that is dot product ux H naught e to the power j k z. So, this will be 1 by 4 mu naught H naught whole square. So, we can compute this 1 by 4 into 4 pi into 10 to the power minus 7 into 25 whole square. So, after multiplication it will come 1.963 into 10 to the power minus 3 joule per meter cube. Similarly, we can find out the We. We will be 1 by 4 epsilon naught E star. So, this will be 1 by 4 epsilon naught by 4 electric field is given minus U by eta naught H naught e to the power minus j k z and dot minus U by eta naught H naught e to the power j k z, like this. So, after simplification this will come eta naught whole square epsilon naught H naught whole square by 4. So, we can substitute eta naught is 377 into epsilon naught in the free space 8.854 into 10 to the power minus 12 into H naught का whole square divided with 4. So, it will come again 1.963 into. So, we can see that both electric energy and magnetic energy are equal into 10 to the power 4 joule per meter cube. So, this is the solution for the B part. We can go to the next problem. In a non-magnetic medium, E equal to 4 sin 2 pi 10 to the power 7 t minus 0.8 x uz volt per meter. Find epsilon r eta, that is the wave impedance eta epsilon r, that relative permittivity, the time average power carried by the wave and the total power crossing the 100 centimeter square of a plane, means from the plane 2x plus y is equal to 5. So, this is the next problem. Now, in the page it is 8th problem. So, here means E field is given, E field is 4 sin 2 pi 10 to the power 7 t minus 0.8 x uz volt per meter. So, this is the given electric field. So, from this we can compare sin omega t minus beta x. So, after comparing from the sin omega t minus beta x, we can see that here beta is equal to 0.8, beta is equal to 0.8 and omega will be 2 pi into 10 to the power 7. So, this is the omega and beta, and because this is a non-magnetic medium. So, epsilon r will be 1 and mu will be equal to mu naught. We know beta equal to omega square root of mu epsilon, and this can be written as omega mu naught mu r epsilon naught epsilon r. Mu r will be 1 and we have to find out epsilon r first. So, epsilon r from this expression will be, so so root means so this. So, we can see this omega root under mu naught epsilon naught into epsilon r, and here means omega, and we know c means that is velocity of light in the free space, that is defined as 1 by root under mu naught epsilon naught. So, mu naught epsilon naught can be written as 1 by c. So, beta will be omega by c as epsilon r. So, from here we can write a square root of epsilon r equal to beta c by omega, beta into c by omega. Beta we know, means that is in the problem it is given 0.8, c is the velocity of light in the free space 3 into 10 to the power 8 divided with omega. Omega is 2 pi into 10 to the power 7. So, after calculation this will come 12 upon pi, 12 upon pi. So, epsilon r will be 12 upon pi whole square. So, epsilon r from this will get 14.59. After getting the epsilon r, we can find out means eta, that is wave impedance, that we know, that is defined as mu upon epsilon equal to, mu can be written as mu naught epsilon naught mu naught mu r divided with epsilon naught epsilon r, and value for this will be means total square root, this will be 120 pi divided with a square. So, a square root of r 12 by pi. So, this will be 120 pi divided with 12 into pi. So, this will be 10 pi a square. So, this is the eta and this is in the ohm. Next part is, so epsilon r and beta, the time average power carried by the wave. So, time average power carried by the wave we can find out by, so this means E cross H we have to find out. So, power that first have to find out. So, time average power will be 1 by T, that is eta naught whole square, means E naught square by 2 eta into ux. So, we can see that in the here means a sin omega t minus k beta x. So, here the wave is going in the x direction. So, power is carried out in the x direction, that is why it is in the x direction. So, directly we can substitute. So, this will be eta, that is E naught square, that will be 16 divided with 2 eta. So, eta is 10 pi square, 2 into 10 pi square into ux. So, it will be 81 ux milliwatt. So, after simplification it will be 81 ux milliwatt per meter square. So, this is the power average. Next part is total power crossing 100 square centimeter of a plane 2x plus y equal to 5. So, 2x plus y equal to 5 in the C part, 2x plus in the C part it is 2x plus y equal to 5. So, unit vector on this plane will be un will be ux means 2 ux plus u by divided with a square root of 5. So, this is the unit vector on this plane. So, power average. So, total power. So, power average will be, so this will be means so this is the power density we have already calculated. So, that is in the x direction. So, just have to multiply 81 into, that is in the milli, minus 3 ux into and into ds means this is per watt per meter square. So, from ds 100 square centimeter, 100 square centimeter means 100 into 10 to the power minus 4 into unit vector, that will be 2, the dot product will be 2 ux plus u by 5. So, here means ux cross ux it will be 1. So, this will total will be multiplied with 2 by root 5 ux dot with u by, that will be 0. So, final answer will be, it will be means 81 into 10 to the power minus 3 into 100 into 10 to the power minus 4, 10 to the power minus 4 into 2 by a square root of 5. So, this will come 724.5 microwatt. So, this is the answer for the last part. We can go to the next problem. So, in the free space, now here in the free space h is given 0.2 cos omega t minus beta x uz ampere per meter. Find the total power passing through a square plate of side. This is a square plate of side 10 centimeter, that means area will be 10 cross 10 centimeter square on the plane x plus z equal to 1. So, first we have to find out the unit vector on this plane. So, unit vector on this plane will be so this is the 9th part. So, for the A part un will be, so x plus z equal to, so that will be, does not matter, a constant. So, ux plus uz by root 2. So, this is the unit vector on x plus z equal to constant, and power will be, total power means passing through the square plate of side 10 centimeter. So, power density will be half eta h naught whole square, and we can see the expression here beta x. So, that means h naught will be 0.2 and here beta x. So, wave is propagating in the x direction. H field is in the z direction and by electric field will be in the either plus or minus in the y direction. So, for this power density will be half eta H naught square. So, half power density into total area with unit vector. So, power passing through that square plate will be half eta. So, here it is in the question it is written, it is free space, that is why we have taken means eta naught, otherwise we have to find out the means eta, like in the previous problem it was different. So, eta naught H naught whole square into ux which is propagating in the ux direction into ux plus uz divided with root 2 into area is means a square plate. So, that is 100 centimeter whole square. So, 100 into 10 to the power minus 4. So, in the meter square. So, ux dot with ux it will be 1 by root 2 and other part will be ux dot uz will be 0. So, final we can write 1 by 2 into 120 pi into h is 0.2 whole square into 1 by root 2 into 10 to the power minus 2. So, this will come after calculation means 53.31 milliwatt. So, this is the answer for the first part. Similarly, for the next part, in the B part it is given a circular disc of radius 5 centimeter on the plane x is equal to 1. So, on the plane x is equal to 1. So, unit vector will be ux, just ux, and so in this problem the power density will be same, and this unit vector and area will be different. Then because area for the circle is that it will be pi r square. So, like that we have to find out Pt equal to half eta naught H naught square ux. So, it will be ux and into pi r square. So, radius is given 5 centimeter. So, 5 centimeter means in the meter 0.05 whole square. So, ux dot ux it will be 1 and we can, because this is free space, so 1 by 2 into 120 pi 0.2 whole square pi 0.05 whole square. After simplification it will come 59.22 milliwatt. So, this is the answer for the this B part. So, in the next problem, if E is equal to ax plus ja by e to the power j k z minus j omega t and h is given k by omega mu into a by plus j x e to the power j k z minus j omega t, the time average Poynting vector is. So, here it is option. So, I have to find out time average Poynting vector. So, time average Poynting vector. So, we know that 1 by 2 real part of E cross H star. Time average Poynting vector will be power average equal to 1 by 2 real part of E cross H star. So, real part of E cross H star equal to 1 by 2 real part of E cross H star. So, E is given Ax plus that Ax or Ux. So, both are the unit matrix, means unit vector. So, Ax plus either can means it depends on the book, either some book use means Ux, some use U by Ax plus. So, in the exam any can come, means either Ux or Ax. Ax plus J by e to the power j k z minus j omega t cross with h. H is k by omega mu a y minus j a x, and that is conjugate, that means e to the power minus j k z plus j omega t. So, we can multiply. So, this term, this exponential term will be 1, and k by omega mu, that will come outside. So, 1 by 2 real part of k by omega mu, and after this we have to vector product of this Ax cross Ay. So, that will be Az and Ax cross Az. So, that will be minus A by plus J A by, and here J A by cross J A by, A by cross A x, H is A by this will be A x, this will be A, wait, A y minus j x, because this is A y minus j x. So, after means a star, it will be minus A y minus j a x, A y minus j x. So, A x cross A y A z and A x cross A x. So, this term will be 0, and A by cross A y, it will be 0, and A by cross A x. So, j square will be minus 1, and then this will be minus, again minus, it will be plus, but A y cross A x will be minus A z, minus A z. So, minus A z, it will cancel out and total will be 0. So, option will be A, null vector. In the next problem, if H field in ampere per meter of a plane wave propagating in free space is given by this, time average power flow density in watt each. So, here it is 4 option is given. So, you have to choose that. So, H is given, H is given Ax 5 root 3 by eta naught. So, in the free space it is given eta naught cos of omega t minus beta z plus A by 5 by eta naught sin of omega t minus beta z plus pi by 2. So, this is the H. So, time average power flow in watt in free space. So, that we know means P is equal to eta naught means E naught whole square by 2 eta naught. So, we know means E naught is equal to eta naught into H naught. So, we can substitute this and eta 1 will cancel and this will give 1 by 2 eta naught H naught whole square. H naught whole square. So, from the given expression H naught will be, from the given expression H naught will be 1 a square root of 5 root 3 eta naught whole square plus 5 by eta naught this. So, after simplification we can take 1 by eta naught outside, 1 by eta naught outside and a square root of, so 25 into 3 75 plus 25. So, it will come 10 by eta naught. So, H naught will be 10 by eta naught. So, power will be, so time average power flow density will be, that will be 1 by 2 eta naught into H naught whole square. So, that will be 100 upon eta naught square, and so this will be 50 upon eta naught watts. So, option will be, so 50 upon eta naught. So, option will be D. So, like this, so all this problem can be solved. Thank you.